Okay, so in this lesson, we're going to look at simplifying cube roots. Now, just like when we were simplifying square roots, we looked at perfect squares. When you are simplifying cube roots, we're going to use the idea of perfect cubes. So let's talk about perfect cubes. So again, these are perfect cubes. Perfect cubes. So we're going to need that. We're going to need the idea of perfect cubes to simplify cube roots. Okay, so remember that when we looked at perfect squares, how we got the perfect squares, we said 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, so on. Remember that? And so if I took the square root of each of these, I would get that base back. So square root of 1 is 1, square root of 4 is 2, square root of 3 is, square root of 9 is 3, square root of 16 is 4, and so on. So the perfect cube, we're going to use the same idea. So 1 cubed is 1. So 1 is my smallest perfect cube. 2 cubed is 8. So 8 is the next perfect cube. And so if I took the cube root of 1, remember what number times itself 3 times is 1, I will get 1 back. If I took the cube root of 8, what times itself, remember this is what I'm saying, the cube root of 8, what times itself 3 times is 8. Remember all that? And so you'd say 2. Okay, and that's what you saw here. And so the next perfect cube is 3 cubed, which is 27, right? Because 3 times 3 times 3 is 27. The next perfect cube would be 4 cubed. So 4 times 4 is 16. 16 times 4 is 64, and so on. And then 5 cubed would be 125. And so notice that these numbers get a lot bigger than these do. So my first one's 1, my second one's 4, my third one's 9, my fourth perfect square is 16. Whereas you see how much bigger they are at that same position? So my first one's 1, my second one's 8, my third one, the third perfect cube is 27, and so on. So there's still an infinite number of those, but remember your perfect cubes. Just remember at least the first 5 or 6 of them. Okay. All right, and then you have access to a calculator, so that's going to help you quite a bit. So let's look at some examples. So we want to simplify perfect cubes. So look at the example. So the example will probably just say something like simplify. Okay, so number 1, we have the cube root of 88. All right, and so I want to simplify this. If possible, it may be that I can't simplify this. So when you're looking to simplify perfect cubes, again, you want to look at the radicand. So is there a perfect cube that will go into 88? That's the question. All right, so obviously you know 8, right? So go off to the side. Actually, you can just do it here. So the cube root of 88 will be the cube root of 8 times 11. Okay? And then just like you did with simplifying square roots, you're going to use the product rule. So the product rule says that when I am taking the radical of a product, then I can rewrite this as the product of each of those radicals, in this case the cube root. So this would be the cube root of 8 times the cube root of 11. And so remember, just like with square roots, you can't the radical, in this case the cube root, cannot be simplified further if the only factor that goes into the radicand is 1. If the only perfect cube that goes into the radicand is 1. All right, so notice that for 11, see 1 is the only perfect cube that goes into 11. So I cannot simplify that any further. But I can simplify the cube root of 8, because what times itself 3 times is 8? The answer is 2. So we get 2 times the cube root of 11. So that's your answer for number 1. All right. So it's just like simplifying square roots, except with square roots you were looking at perfect squares. With cube roots you're looking at perfect cubes. All right. Okay, number 2, we have the cube root of 81. Okay, cube root of 81. Now again, you have access to a calculator, so look at your perfect cubes and see if I can simplify this. So So is there, and you always want to use a larger, so is there a perfect cube that goes into 81 besides 1? So you may say, well, what about 8? All right, well, try 8. So 81 divided by 8, you see 81 is not divisible by 8 because you get a remainder. And so let's try 27. So 81 divided by 27. And there we go. So notice that 81 is 27 times 3. And then just like we did with the square roots, you need to ask yourself, is 27 the largest perfect cube? And it is, because if you look at 3, the only perfect cube that goes into 3 is 1. So therefore, I'm going to put this in place of 81. So I get the cube root of 27 times 3. And then using a product rule, I can write this as the cube root of 27 times the cube root of 3. And again, I cannot simplify the cube root of 3 because the only perfect cube that goes into 3 is 1. But I can simplify the cube root of 27 because what number times itself 3 times is 27. So what cube is 27? And the answer is 3. So this is 3 times the cube root of, this is 3 times the cube root of 3. That's your answer. Okay, number 3, let's suppose number 3, you have this. And number 3. Okay, so number 3, we have the cube root of 35. Cube root of 35. So is there a perfect cube besides 1? Is there a perfect cube? Remember, these are your perfect cubes right here. So is there a perfect cube besides 1 that will go into 35 evenly? And the answer is no. So that means that the cube root of 35 can't be simplified further. So it can't be simplified. Okay? So, but what that means is this, that you can say cannot be simplified. You can also say the cube root of 35 is equal to the cube root of 35. Okay, so that would imply it cannot be simplified. Okay? Number 4, let's suppose we had the cube root of 108. All right, cube root of 108. So the index is 3. That's a 3 right here. And so what perfect cube will go into 108 besides 1? So you could try 8. So 108 divided by 8. And the answer is no. 108 divided by 27. Yep, there we go. So 108 is equal to 27 times 4, right? And so the only perfect cube that goes into 4 is 1, so that's what I'm going to use. So 27 happens to be the largest perfect cube. So this will become the cube root of 27 times 4. And by the product rule, this becomes the cube root of 27 times the cube root of 4. And the cube root of 27, since 27 is a perfect cube, the cube root of 27 is 3. So I get 3 times the cube root of 4. Okay? Number 5, we have the cube root of 10 divided by 27. The cube root of 10 divided by 27. So remember in the previous lesson when you talked about the quotient rule? So that's what we're going to use here, the quotient rule. So this will become the cube root of 10 divided by the cube root of 27. And just look at this. Can I simplify the cube root of 10? So is there a perfect cube other than 1 that goes into 10 evenly? No. So the numerator is going to stay the cube root of 10. The denominator, what number times itself 3 times is 27? So what's the cube root of 27? The cube root of 27 is 3. So there's your answer. So the answer is going to be the cube root of 10 divided by 3. Number 6, we have the cube root of 81 divided by 8. The cube root of 81 divided by 8. Okay, so using a quotient rule, remember when you take like when you did the square root, so the product and quotient rules still work with cube roots as well. Works with any root. Okay, so I'm going to write this as the cube root of 81 divided by the cube root of 8. Okay, so I know the denominator was a cube root of 8. So what times it's 8's a perfect cube, right? So what times itself 3 times is 8? The answer is 2. Now let's look at the cube root of 81. So let's think about 81. So what perfect cube, if any, goes into 81? So we know that 8 won't, but what about 27? So 81 divided by 27, yep, that's it. So this is going to be, I'm going to write it here. So the cube root of 81 will equal the cube root of 27 times 3, right? And so using a product rule, I'm going to get the cube root of 27 times the cube root of 3. And the cube root of 27, 27 is a perfect cube. So the cube root of 27 is 3. So I get 3 cube root of 3. So 3 cube root of 3. And again, just like we mentioned before in previous lessons, just make sure your index looks like an index. Okay, so make sure that 3, the cube root, the root 3 is where it should be. Okay, and then finally number 7. So this was a short lesson. So number 7, we have the cube root of 40 divided by 27. Cube root of 40 divided by 27. Okay, so by the quotient rule, I can rewrite this as the cube root of 40 divided by the cube root of 27. Okay, now let's talk about the cube root of 40. Let's think about the cube root of 40. So besides 1, is there a perfect cube that goes into 40? 8. That's correct, 8. So I can write this as the cube root of 8 times 5, right? And so using a product rule now, I can get the cube root of 8 times the cube root of 5. And remember, 8's a perfect cube, so the cube root of 8 is 2. So this becomes 2 times the cube root of 5. And so that's the numerator, 2 times the cube root of 5. The denominator, remember, 27 is a perfect cube, so it's a cube root of 27. So what times itself 3 times is 27? The answer is 3. And so that's the answer there. Okay? So those are the problems dealing with simplifying cube roots. So that's the lesson on simplifying cube roots. So that will take care of this lesson.